The second part of section 2.7 talks about what's called the coefficient of determination, which is really a fancy name for the R-squared value. So we talked about R values, the correlation coefficient. Now we're looking at the R-squared value, or the coefficient of determination. Kind of the running data that we've been looking at for 2 or 3 different sections. It's been the one where we talked about the ads purchased versus the cars sold. And we said that, okay, if we had an increase in advertising, that usually led to an increase in car sales. However, maybe I'm that person that's selling those ads and I go to my boss and say, hey, I need a raise. You know, look at this data. Every time that I've sold more ads, that's led to increased car sales. But my boss wasn't buying it. My boss said, well, there's other factors, other things that might have contributed to this increase in sales, other than just the ads that you kept selling. So here's what I want you to think about. I want you to pause the video here in a second, and I want you to list 3 other contributing factors that may help you account for your increase in car sales, other than that increase in ads purchased. So come up with 3 different things that you think, okay, well, it wasn't really the ads, it was something else that led to those car sales. So go ahead and pause the video and write down 3 things that you think. All right, well, this is a case where I wish we were in class right now so I can get some of your feedback. But in the past, some things that people have mentioned that might contribute to an increase in car sales. Some of them talked about, okay, well, maybe there's just a sale going on. So there's some sort of deal going on. They have cash back deals. They have special financing deals, things of that sort. So they just have special deals going on. Some people talk about the time of year, because different times of the year sometimes lead to increased car sales, whether it be it's Christmas time, it's during the summer, whatever the case may be. But the time of year, they have these different times of year where car sales are going to go up. Maybe you said, well, it's just word of mouth. It wasn't really the sales. Maybe we just had people talking about this car dealership, and they started going there, and they liked what they had there. And you may have come up with a lot of different things that would contribute to the increased car sales, other than just the ads that we kept selling. So I go to my boss. I've asked for a raise because I think my ads that I've been selling are increasing the car sales. He came up with all these other ideas. He said, all right, well, all these other ideas are really what's increasing the car sales. Let's see if we can put a percentage to what part we think is due to the increase in ads, what part is due to those other factors. So there's no wrong or right answer here, but what percent of your increase in sales is due to increased ads purchased, and what percent do you believe is due to all those other factors combined? So again, I want you to pause the video and just come up with, okay, well, what percent is due to the increase in ads, what percent is due to those other factors? Well, whatever percentages you came up with, like I said, there's really no right or wrong answer. The biggest thing is whatever you chose. Maybe you decided 80% were due to the ads. We had to make sure we add up to 100, so 20% would be due to those other factors. But again, it was kind of a guess on that. It was kind of a shot in the dark. So the question is there any way to know? Well, statistically, there is a way. And that's what the second part of section 2.7 talks about. All right. Well, again, we've been using this data a lot, where we've had the ads sold and the cars sold. But I'd like you to go ahead and enter that data into your calculator. And then go ahead and find that correlation coefficient, the R value for that data. So remember, that's going to be in our linear regression. So you're going to enter your data. So you put cars sold in the L1, and you put, I'm sorry, ads sold in L1, cars sold in L2. So once you have your data entered in, you should be able to go to Stat, to Calculate, and we chose linear regression again, fourth one. And so this is what the calculator hopefully gave you. So our R value, if we were to round it to 2 decimal places, is going to be 0.92. If you remember back when we used this data before, that was the R value that we got. So that told me there was a very strong correlation, but it still doesn't really tell me percentage-wise what effect the ads had on how many cars that we sold. Well, we're going to take it a step further. We're going to do the R squared value. Well, notice the R squared value is also listed there. And the R squared value is literally that. We're going to take the R value and we're going to square it. So our R squared value is 0.84 for this example. So what's that tell us? Whenever I find the R squared value, the R squared value is going to indicate, in this instance at least, that 84% of the increase in cars sold was due to the increase in the ads sold, which means the rest, or the other 16%, is a combination of all those other factors. So if you go back to the percentages that you came up with initially, you can see, well, how close was I to what the statistical percentages would it really tell me? Now that 16%, we can't really say, okay, well, of the 16%, 3% is because of the time of year, 5% is because of the sales we're having or whatever. But we know altogether that 16% of those other factors, all those other factors would contribute to 16% of the increase in car sales. So the R squared value basically tells me, all right, this is the percentage of effect that the X has on the change in Y. Something to keep in mind, remember when we did R values, we said it couldn't be less than -1, it couldn't be positive, or couldn't be more than +1. So what that tells me is R squared has to be between 0 and 1. In other words, you should never have an R squared value that's negative, which kind of makes sense because that would mean I have a negative percentage. And we know that couldn't happen as far as a contributing factor. So finding the R squared value is really no different than finding the R value. But what it's going to tell me is this percent is the effect that the X had on the Y. All right, so those two things for section 2.7, being able to use the residual plot to make a decision on whether we should be doing a linear regression or not. And then also being able to find the R-squared value, but more importantly, be able to figure out what's the R-squared value actually telling me.